Hi everyone, this is Mrs. J, and today we're going to be creating and solving compound inequalities. So if a quick warm-up for you here to solve the following two inequalities, please pause the video and give it a try, and we'll check in a few seconds. Alright, go ahead and check here. So remember, solving an inequality is just like solving an equation. So here we had to use distributive property, and then we had to move our variables to the same side, then just finish solving. And here, if we have the x is on the right, and notice that the closed side is facing the x, we can rewrite it like this. X is less than or equal to negative 11 over 10. On part B, notice that we have fractions, which remember we can clear by multiplying the entire equation by your LCD, which is 4. So when you do that, 4 divided by negative 2 is negative 2x, distribute to the 5, and then this 4 and this 4 cancel out. And now you have an inequality with no fractions, making it much easier to solve. However, be careful in this step here. Remember, whenever we multiply or divide by a negative number, we need to reverse our inequality sign. Alright, so today we are going to be focusing on what are called compound inequalities, which are made by combining two or more simple inequalities. So there are two types of compound inequalities. We call them and compound inequalities or compound inequalities. So whenever you see and like this, x is greater than 2 and x is less than 6, we want the times when both inequalities are working because of the word and, telling us that we're actually trying to find the intersection of the two. So let's look at this first example. X is greater than 2 and x is less than 6. So we want all of the numbers that work for both of these inequalities. So visually, if we were to graph x is greater than 2, we would use an open circle at 2, and it would be everything to the right, all of the numbers that are bigger. If we're graphing x is less than 6, again, open circle at 6, and then everything to the left, which is smaller. But since it's where it's this and this, we're actually looking for the overlap between the two, again, the intersection. So the only inequality that we actually want is actually everything from here to here. So these are the only numbers that actually work for both. And we can actually rewrite this a little bit more efficiently. We start with our lower boundary, which is 2. And then we want everything bigger than that, but less than 6. So any compound inequality that involves and, we should be able to write it like this, as a single inequality. Now, if you have a compound inequality with or, we call that a union. So it's actually two separate areas, and it can work for one or the other. So we're actually not looking for overlap here. So if I were to graph this, x is less than or equal to 2. So here, again, it's less than or equal to. So I'm going to actually color in my circle, and then it's everything to the left, which is less than. Or x is greater than or equal to. So again, I'm going to make a solid dot there because it's or equal to, and then everything to the right. So here it doesn't matter that they don't overlap because it's either this or this would work. Okay, so now we're going to learn how to solve a compound inequality. So solving a compound inequality is much like solving a regular inequality. We're trying to isolate x. So if you look here, if I would like to isolate x, we know that we would want to subtract 2. Except now, instead of just doing it on both sides, we have to make sure we're doing it in all 3 regions. But still, it's that same idea of subtracting 2. So 4 minus 2 is 2, and then less than or equal to x, and then less than or equal to 6. So this is actually our answer. So we can graph this. 2 is our lower boundary, and it's included. 6 is our upper boundary, which is also included, and then it's everything in between. All right, let's try another one together. So here, if I look, our first step would be to subtract 3. So we just need to make sure we're doing it to all 3 regions. So this gives us negative 8 is less than or equal to 2x is less than or equal to 6. And then, of course, our next step would be dividing by 2, so we're going to do that here as well. Negative 4 is less than or equal to x is less than or equal to 3. And we are all set, and this is our answer. So to graph it, our lower boundary is negative 4 with a closed circle. Our upper boundary is positive 3, again with a closed circle. And then it's everything that's in between, so it works for both. All right, so at this time, I'm going to ask you to pause the video and see if you can give this problem a try. All right, so let's have a look. For the first one here, we just add 3 to all 3 regions, and we get 1 is less than x is less than 8. So to graph it, 1 with an open circle is your lower boundary, and 8 with an open circle is your upper boundary. For part B, it's 2 steps. First, subtract 2 and then divide by 3. So it's negative 4 is less than or equal to x is less than 2. So notice that these don't always need to match. So negative 4 has a closed circle and 2 has an open circle. All right, so now we're going to try to solve and graph a compound inequality with OR. So we're actually just going to solve them each separately. So here I would simply add 4 to each side, giving me x is greater than 5. And then on the right, I would do the same thing, giving me x is less than 1. So our answer is x is greater than 5 or x is less than 1. So to graph that, here's 1. So it's everything less than that. And then here's 5, and it's everything above. All right, let's try one more union problem together. So on the left part of our inequality, of our compound inequality, we can divide by 2, giving us x is less than or equal to 3. On the right, we would divide by 3, giving us x is greater than 4. So this gives us x is less than or equal to 3 or x is greater than 4. So any numbers less than or including 3, which is why we use that closed circle, and then everything bigger but not including 4. So you can see there's actually only a really small gap of numbers that doesn't work for this compound inequality. All right, go ahead and pause the video and see if you can give this one a try on your own, and we'll check your answer in just a few seconds. Okay, so here we can solve them each separately, and what we get is x is less than 4 or x is greater than or equal to 6, which you can graph just like this. All right, the last thing we're going to practice doing together is actually kind of the reverse. So we're going to see if we can look at the graphs and write the compound inequalities that are represented. So for this first one, you can see that it's a region in between 2 boundaries, so it's going to be an AND problem. So we start with our lower boundary, which is negative 8. It's everything bigger than negative 8, not including it, but everything less than 2. So that's how we could describe that intersection. So everything between negative 8 and 2, not including those numbers. For the second one, you can see this is going to be an OR problem because it's this region or this region. So let's describe the region on the left. That's when x is less than negative 2, or, and then the region on the right is when x is less than, or greater than 5. For the third graph, again, we have that intersection. So we'll do our lower boundary, which is 1. This one, it's included because it's a closed circle. And then we have our upper boundary, which is also included. So we put 4. So it's 1 is less than or equal to x is less than or equal to 4. The next one, similar except the boundaries are not included. So again, our lower boundary is 3, our upper boundary is 7, and the numbers that work are everything in between, not including those boundaries. And last, we have a union. So we'll do an or compound inequality. So the first part, the part on the left, is when x is less than 2. And then we can say or when x is greater than 6. There you have it. All right, so that is all for today's video. Thank you so much for watching.